All right, it says the table shows the number of acres A of land recommended for 8 horses. What is the average rate of change from 3 horses to 10 horses, and what does it mean? So we're looking at the change going from 3 horses to 10 horses. And so the acreage changes from 4.5 to 15. Now, to find the rate of change here, what you want to do is you want to take your um, change in your dependent variable. And so that's usually y. So you're going to be doing y minus y over x minus x. Or in other words, this is the dependent variable because we don't have y's and x's here. So this is the dependent variable. And in the denominator is the independent variable. Now, to me, sorry, that's a terrible D. To me, in this problem, the hardest part is figuring out which one is your dependent and which one's your independent variable. Usually, if you have something like time, that makes it a lot easier because time is always your independent variable. So if we had time over here, that would go on the bottom. Another common one is money, and if you have money, money is a dependent variable and it would go on top. But we don't have either of those. So we have to figure out which of these is dependent upon the other. Is the number of horses that you have dependent upon the number of acres of land you have? Or is the number of acres of land you have dependent upon the number of horses? And I've been thinking about this for a while, trying to figure out how best to explain which way this goes. And I think the easiest way is to say you could have 15 acres and not have 10 horses. You could have 15 acres and have 3 horses, right? So the number of horses is not dependent upon the number of acres. So if I have 15 acres, that doesn't mean I have 10. But if I have 10 horses, that does mean that I need at least 15 acres. So acres is the dependent variable. So let me label this. So I'm going to call this my y, or the dependent variable, and this is my x. So that's what we will need to do. We want to take the change in the acres over the change in the number of horses. So all I'm going to do is subtract these. So I'm just going to do 15 minus 4.5. 15 minus 4.5. And you have to be careful now. Since I did, can't get my pointer to work. Sorry. Since I did this number minus that number, I have to be consistent on this side, and I have to do the 10 minus the 3. So if you did, so again, let me say that again. Since I did 15 minus 4.5, I have to do 10 minus 3. Otherwise, you're not going to get the correct answer. Okay. So now I'm going to do the 10 minus 3, like I said. 10 minus 3. And what I end up with is, let's see, 10.5 over 7. And if you take 10.5 divided by 7, you get 1.5. So the rate of change is 1.5. So now if we go and look at our answers, um, A says that the rate of change is 3. That's not correct. B is 1.5. And D is 1.5. So the answer is either B or D. So now we need to see which one explains what the 1.5 means. So B says it means that for each horse, it is recommended that you have 1.5 acres of land. And in fact, if you look right here, that's what this says. For one horse, you need 1.5 acres of land. The other one says it means that it is recommended that you have no more than 1.5 acres for each acre of land. So the answer is B. All right. So keep working hard, doing great, and you will master the math.